For this you'll need a microwave and a bar of soap. Put the bar of soap in the microwave, or a few bars, turn the microwave on for a few minutes, and watch the soap expand. It's a fun, quick demonstration, but the question is, why is the soap expanding? Well, some brands like Ivory have a bunch of very small air bubbles spread all throughout the bar. And just like the air we breathe, there's some water vapor in those air bubbles. When the microwave heats up those pockets of air, the molecules of air and water vapor start to move faster and begin to expand. This results in those small bubbles inside the bar of soap expanding quite a bit. The hotter a gas is, the more space it takes up. The colder a gas is, the less space it takes up. That's because the hotter a gas is, the faster its molecules are moving. It's why a basketball or a football or the tires on a car will gain or lose pressure depending on the temperature. In fact, air pressure in a tire typically goes up or down 1 to 2 pounds for every 10 degrees of temperature change. It's why convection, the idea that heat rises, is a thing. Because as we know, when a gas like air is heated, the molecules expand, and when they do that, they actually weigh less than the other air molecules around them. Just like how a bubble in a pool rises to the top because it's less dense than the water around it. Examples of convection range from how water boils in a pot, the fact that candles point up, hot air balloons, or even just the wind. And as for why a microwave heats up anything at all, remember how temperature is directly related to the movement or kinetic energy of molecules? Well, when microwaves, which are made up of alternating electric fields, pass through something like a bar of soap, the water molecules inside will try to adjust themselves. Much like a magnet will try to line up with the opposite pole of another magnet when brought close together. And all that adjusting results in increased molecular movement, which, as we know, means the substance is getting hotter and also expanding.